Hi, I'm Jessica. I'm here with Senior Sales Engineer John Goodgame, and we'll be talking to you about developing your first set of interfaces with Health Connect. All right, so a few things that we're going to talk about during this section is really around building or making recommendations for key aspects of your interface build process. That would be everything from schemas, routing rules, data transformations, host names for components, even structuring your databases and your namespaces, which we'll learn about more in a second.
So, databases, architecture, and naming. It seems like it's fairly obvious, but what you really need to do as you're building your system out, understand that you're creating a structure underneath. It's a database system where iris.dat is going to be the name of the database file. For every namespace, and not always, but usually every namespace has its own database. So you can imagine if I put everything in the same folder, I'm using the same folder with iris.dat and overwriting it multiple times. So you've got to build a structure as you name your namespaces so that it makes sense. So if I name a namespace, Mass General, or I name it Ascension, or I name it some other identifier for our environment, then that will be built within the structure. If you look, it's like we get installed, we put it inside Iris for Health, then there's an MGR directory, which is the management directory of the system. And then in here is the namespace. So in this case, I have a demonstration namespace, I have a fire server namespace, and as you can see, they both have iris.dat at the end. So it's important that you maintain these structures as you build. And if we go on to the next.
Small disclaimer, you always want to save your databases in a separate data volume than your installation guide. So it should always have some kind of /db. For the purposes of this, we are just showing a sample, but do not save your databases in the MGR directory.
Yeah, that's... yeah. Okay. So these are the rules around naming the namespaces. It has to be between 1 and 64 characters. It has to be alpha or start with a %. It can include alphanumeric dashes, underscores. Important to determine organization strategy for namespaces, which is what I was just talking about. So, it's important, especially in large installations, that you understand a way for people to navigate the system. It sounds silly that maybe you have 10 namespaces, maybe you only have 2, maybe you only have 1. But there's reasons to have different namespaces sometimes. And when you do that, you want to make sure that if you name a database something, that you actually do a path that contains the name that you've named that database or the namespace. Some
examples of why you might create separate namespaces for those who are asking that question in their heads. Typically, we try to keep interfaces consolidated into a single namespace, but there are reasons why we might expand that. For some multi-region or multi-tenant organizations, it makes sense to separate interfaces based on that region or that tenancy. So we do have geographic variations or that kind of distinction. Organizations might choose to create separate namespaces because they might want to have different purging policies on those messages. So as an example, HL7 can be chatty at times. One of the chattier types of HL7 interfaces are device interfaces. Devices can send a ton of messages all at once, and there's no need to keep that data for as long as your other kind of traditional HL7 interface messages. So in those situations, we might recommend putting those in a separate namespace that has a more aggressive purge policy, just to limit the amount of space that you're picking up. And so we're happy to consult with you on, what's the, how many namespaces make sense for my given scenario. You'll hear us say this a lot, as few as possible, but as many as you need is our rule of thumb.
Yeah, and I just would point out, just underscoring, it's tied to security. One of the nice things about namespaces, it's very closely tied to our role in resource-based security model. So Jess mentioned multi-tenancy. If I'm and some of our Health Connect Cloud customers are vendors that sell services to their customers, they have to make sure that their customer can only see their interfaces and no other ones, right? Namespaces, very, very clean way to implement that sort of thing.
And so when we talk about the namespace is usually equivalent to the database. So keep in mind that means that they've segregated all that data too.
Yeah, physical isolation
yes.
to data. Yep.
Yep. So productions, best practices in terms of naming your productions, keep in mind, because of our environment, when you're mirrored, you don't want to name a production something that's specific to a particular server, right? You want productions to be something that you can transfer from one location to another, because the mirror actually is going to have it in both locations. So typically you'll see something like, main integration, or you'll have like the name of the customer or a short abbreviation of it with integration 1 or something like that for the name of a production. It's not unusual for the names to be something very simple in terms of just we just want to say this is our integration engine, but also a namespace is going to have, sometimes it's going to say device or it's going to say FTP, and those are the ones that Jess was just talking about, where you have a different retention policy for those messages. But the idea is just to make it very simple in terms of identifying what messages are being processed through that particular production. Now, namespaces can have multiple productions in them, but that's very unusual, especially for a customer. You'll see people who train have multiple productions in a namespace, because we'll stop one and start another one just as an example, or for training purposes you might do it. But in real life, typically there's one production in a namespace because only one can be running at a time. So a lot of times you'll see a namespace and a production. When you look at the management portal, there's a lot of information at the top of that management portal. It says things like the name of the instance. It'll say Iris for Health, for example, or it'll say Health Connect. And then it'll have the name of the namespace, and then it'll have the name of the production. So all that sort of tiers down. You don't need to rename the production the full length of this is this instance, this is this namespace. Just something simple that is descriptive of what it's being used for.
I didn't know if you wanted the visual to go with
sure.
it.
Sure. So, yep.
I hit it.
Just click on it.
I did. It keeps pausing.
Here, how about this?
Oh, that's why. Sorry. Here I was trying to help.
There we go. So we're just going to create a namespace and the database. And one of the things you can do, and just as we watch this, it's fairly simple. You're just adding a new namespace. And as you can see, it says, create new database down here. In this case, I'm doing day in the life, DITL. If anybody catches the mistake I made, it'd be interesting. So the name of the database is DITL, but keep in mind the database is actually named iris.dat. So it's really important that I make sure I put it in a pathway that I can identify.
In the DB volume.
Yes. So in this case, again, this is just so you know what it takes to create this. It's not anything complicated, but sort of take away the black box of a namespace and a production. So anyway, we're just gonna finish this. We're gonna create, in this case, I create a separate code database. So I've separated my messages from the code base. So if I do custom functions or what have you, I could actually share that code database with other namespaces if I wanted to, so that I'm not creating multiple different versions of the code. So in a case where you have 4 or 5 namespaces, do you really want to create 4 or 5 different code sets? Typically not. I mean, there might be a reason to it sometime, but if you're all running, the same team is actually managing and building custom code, a lot of times you want to share that code set. So usually you'll put in something where we'll just have a single code set. So this takes a couple minutes. I actually think
So it's important to note that this is really for our Health Connect folks. For the Health Connect Cloud folks, this is not a screen that they would typically see.
Right.
And
so it's complete. Typically you go through and just make sure there's no errors or anything like that. And then It's closed up. Yeah. But again, just to sort of take away the black box of how does the namespace get created and how do you determine what the path looks like, it's very simple. And as you can see where it has the two different resources there in terms of the codes. Okay. Go. And the one thing that I was going to say also at the end, it automatically creates a foundation production. So, and of course, there's nothing in it in particular, but there's a production there that's already named. You could add more productions if you want. That's it.
So, hi, I'm Jessica. I'm here with Senior Sales Engineer John Goodgame, and we're going to talk you through the interface engine basics. So, the first thing that we talk about when we're performing or when we're going through a net new Health Connect installation is naming conventions. Naming conventions is a hotly debated topic. When I say that, I have spent the entire first day of a kickoff on naming conventions. It is a seriously big deal. And I'm not just like overemphasizing naming conventions. So what are we talking about with naming conventions? Well, the big thing about naming conventions is if you think about how long an interface engine stays up in an organization, they're looking at getting anywhere from like 10 to 20 years out of that engine, right? So it's a big investment. It's something that's going to stay around for a long time, and they're laying the groundwork of how they want to organize things. It's a big deal. So usually they're really mad with how things are organized right now. Someone made that decision 10 to 20 years ago, and they want to, kick
and
that
someone
person.
Still wants it though.
And so, and they're like, we are entering a new era of independence where we can make this whatever we want, which is very exciting, but very daunting and leads to a lot of argument. So the first thing that they have to make a decision about is what they're going to call everything. And it's never the same across the board. First decision, we talked about the instance names, namespaces. How many do you want? We provide some recommendations based on the types of interfaces in their organization and their setup and things like that. So packages in Health Connect are really the organizational structure that we see most often. It's really how we group everything. And so packages are really important because when you look at things from different listing structures or almost like a directory structure within the product, you're going to see everything organized based on packages. Typically with packages, there's a kind of main package and then there are sub packages underneath of those. Your main package is typically tied to your organization acronym of some sort. So Main Hospital Midtown, MHM, would be what we would have our main package be. Everything from that point on goes under that main package. So anything that you're building will start with MHM in that case, and you would continue down the line. I mentioned this concept of sub-packages. Sub-packages is how we then group things under that main package. Think of like your desktop. You have folders on your desktop. They're organized in different ways. You could have folders within those folders. That's what packages and sub-packages basically do. So examples of sub-packages within our package would be DTL or RR or util for data transformations, routing rules, utility functions. It's a great way to organize things. Sometimes we'll organize things based on the source or the target of what that item is doing. So we might see things like an Epic package, or we might see an MDM package or a SOAP package that might be done by protocol. Really dependent on the scenario, but that's something that, InterSystems people can walk you through. Components would be the third big naming convention that we see. Put some examples here at the bottom. When we look at the production configuration page, which we call essentially the mission control center for your interface building and maintenance, right? How do I want to see that? And it's really important to make it appealing to the eye, right? It's all about finding things quickly. It's being able to, because remember, we want to be able to organize things and build things for not just the 9 a.m. awake interface analyst who's running messages through a test environment, but also for that 2 a.m. groggy interface analyst that gets woken up by the pager saying that one of the interfaces is experiencing some issues and needs to find it really fast. So we really want to be able to make these things efficient in their naming conventions and clear. So some examples, a very simple example you see here is for a business service reminder. Business services take in data within Health Connect from Epic ADT. No spaces, no dashes, very simple. We have a direction, we have an application name, we have a message type, very simple. Another variation of this naming convention is from underscore epic underscore ORU dash SIU dash or underscore and then this number. So in this case, we have that same from directionality, epic being the connecting system. We have multiple message types coming over this pipe. So we see them delineated with a dash so that it's clear that to the user that there's both an ORU and an SIU message that could potentially be coming over. And then in this case, this last number is a numerical representation of the connection within the EMR. So for them, they could say, all right, I can take this number, I can go into my EMR, I can search for this, this connection, and I can see what's going on the other end very quickly because there's a link between the two. So we encourage, all variations. Usually what we recommend is that this is a conversation that happens with the entire interface team. At the end of the day, a decision does need to be made. We could talk about this for hours and hours, but we do recommend that there's input provided from all members of the interface team so that everybody feels really comfortable with the decision that's made.
Yeah, one of the things you need to do when you start this process is identify any segregations that your enterprise has. For example, there are some sites that actually are managing interfaces for other groups. So they need to segregate that, whether that's within a particular namespace or whether it's by segregating the data in multi-tenancy. But some of that naming conventions sometimes can get complicated by the type of business that the group is in. So occasionally you'll come across a name that has 6 or 7 components in it. You want to keep it to as small as possible, but there are occasions where you see that and it's done for a reason, and it can be confusing, but it's worth the effort to figure out and to talk with the people who are developing to understand why they do it that way.
One of the reasons we also do a soft go live is usually as part of our initial build process. We start with these naming conventions, and after the first interface build, people want to change the naming convention. Yes. So we don't want to get too far down the road with a naming convention after we've used it for a bit that maybe people have some, where there's opportunities to improve that naming convention for the group.
So one of the beauties of our system is that you have the capability to make your own custom format. So when we talk about REST APIs, what that typically means is that there's a format coming in that maybe you want to save as a message. And so we create a message body type that matches whatever that format is. So in my demonstration instance, I probably have 30 or so different message types. Some of them are from REST APIs. Some of them are standard ones that are standard based, like the ones you see up here. But really the strength of our system in terms of dealing with custom formats and actually putting it into a database so that people can actually search on it and treat it no differently than we treat our HL7 messages. Mm-hmm. It's a huge strength.
Let's talk about interface architecture. Then we're going to build a simple interface. Services, processes, operations. If you forget or if you come away with 3 terms from this workshop, services, processes, operations, the bedrock of an interface within Health Connect. Business services are going to take in information. Business operations, send data out. Processes are going to do all of your heavy lifting, your routing, your transformation work, all that fun stuff. So your services, your operations, they're super light in the sense that they're not doing too much of the heavy lifting, right? They're just either firing off or they're just catching a bunch of stuff, right? On your services side, when we receive a message, we have to tell the other system that we received it. There is a name for that kind of message. We received a message and then we sent a message back saying we got it. Does anyone know what that response is called? I heard it.
I heard it, yeah.
What was that? ACK, yes. An ACK or a NAC. An ACK is good, a NAC is bad. So a NAC means that there was some kind of issue working with that message and we need to tell the source system.
Who knows what they stand for? That's right. What's the other one?
Negative.
Right. Excellent.
You made me question it because I was like ACK. It's acknowledgement, but like acknowledgement code now, but not now either. Okay, so your your service, right? It's receiving messages on typically a TCP connection, because we're going to be talking about HL7 message this whole time. You'll hear TCP over MLP. That is the phrase for all connections. That means we're firing off HL7 messages with a particular framing within that TCP connection. And that service's job is to catch it and then to shoot back an acknowledgement. So it's catching and shooting the whole time. When that service receives a message, it immediately forwards it to our process that's doing the heavy lifting, as I said. We'll get into all of that different logic. The operations job is to continue to throw the ball or throw the message out there, and it's going to receive an acknowledgement back, right? So it says, did you get it? Did you get it? And then it's going to get a message back that says, yeah, I got it.
Some simple concepts, real quick. Our services, when they receive a message, will not send an acknowledgement back until we've saved the message. That's why we guarantee delivery. So if you think about that, the sending system is waiting for an acknowledgement saying, did you get my message? If it doesn't get it, it's going to send it again, typically. Not always, but typically. So one of the keys to our structure here, our architecture, is that don't send any acknowledgement until you've saved that message, because then you know that it's going to be delivered. All right, so there are different kinds of acknowledgements, and I'm just going to do this real quick. We typically, and a lot of systems do, but typically we send what's just called, an initial acknowledgement. Right, so it's right when the message is received, we say, okay, we saved it, send an acknowledgement. There's also another kind of acknowledgement called an application level acknowledgement. And that is for really complex systems. So if I'm sending a message in, it's going to go through a process, it's going to go through an operation to another system. And that other system is evaluating that message to determine whether or not it's going to accept it. And then it sends us back that acknowledgement or that negative acknowledgement. And then we send it back. That's called application level acknowledgement. And it's unusual these days, but it does happen. So if you ever get into a situation where someone's saying, no, I've got the messages, I see that they came in, but the other system's saying they didn't get an acknowledgement, it might be a clue that that type of acknowledgement is taking place.
One other kind of note before we leave this. There is an acronym to describe how messages are processed in healthcare, and it has to do with the order with which they're processed. Does anyone know what that acronym is? Yes, first in, first out, FIFO. FIFO is super crucial, and everything that we do within Health Connect is built with FIFO in mind. So by default, our interfaces operate in a FIFO mentality, meaning the first message you get in is the first message that goes out the door. Super important within healthcare. It's very important. Almost every HL7 situation involves maintaining FIFO. Health Connect does that by default.
So one thing I'd point out too with this, HL7 is a great transactional processing format. It's meant to, first in, first out. Each step along the way, it gets processed, right? Fire is typically used a little bit differently. And the reason I bring this up is because you're going to see more of this. Fire is a request. So a lot of times those are through REST APIs. And what happens is we get a request in, we don't care what order it came in, because you're asking for information probably on a mobile app for what's my result, right? So I don't care if you get your result faster than Jess gets hers. So those are not necessarily FIFO. Those are a little bit different. And so when you come across someone using Fire for mobile apps or something like that, keep in mind that that process doesn't necessarily need to be FIFO. It's good to sort of make sure that of that up front. Like if you're having a conversation around it and someone's saying, oh, I'm doing a REST API and I've got 10 connections, it's probably a big hint that probably doesn't matter, but sometimes you need to verify.
Amazing. So I think we're gonna move at a slightly more accelerated rate now, just given
This
timing.
is super simple.
Okay. So building your first interface, what we're gonna do is we start by going to our mission control center, which is our production configuration page. And we leverage the user interface to build out these components. So we usually start by building out a service. The service, we give it a name based on the naming convention we've all agreed upon prior to building our interface. We'll talk about categories in a bit, but they're very important. We then typically choose to let the wizard create a new process. We sometimes refer to these as routers, meaning that once that service receives the message, it's going to send that message to this process or this router. We give it a schema. Typically, the schema is something that's custom. And in this case, because it's a file adapter, we specify that connectivity information. But if it was like a TCP connection, it would be something like a port or an IP. Similarly, for operations, we're driving all of this through the user interface. That is the key theme. We talked about ease of use. Key theme is to drive all this through the user interface. We'll give it the same naming convention that we've decided upon for our components. Same idea. We give it a display category, which we'll talk about in a bit. And similar to the past, in the other situation with your operations, you're also going to have some kind of connection. So you'll fill in the settings appropriately based on that connectivity information.
Did we click?
Oh, you're updating the, is it frozen? Oh. We can accelerate.
Yeah.
No, we can't. Okay. That's the, that's the basic build. So for business hosts, I know that wasn't the end of the video, but we'll come back to it. So that's really how we typically build out our services, our processes, and our operations. We set up the connection settings on the left and the right, or on the right side panel, based on the type of connection we're working with. We talked about naming conventions as well. All right, categories. I skipped over this piece. They allow you to group like interfaces together. Categories are paramount to your both your naming convention strategy and your rollout. The reason why is, think about the situation where I have 1,000 interfaces or even 500 interfaces. Imagine our production screen. Can I show it?
Yeah.
Does that
Go ahead.
show?
Yeah.
Okay.
Well, you have to slide it over.
Oh, I have to slide it over. Oh, okay. Wah. There we go. Amazing. Oh, do I have to then do
You
that?
could look
Oh,
up there.
thank you. All right. So imagine a situation where this screen has 1,000 interfaces on it. And I woke up at 2 a.m. because something went wrong. And I need to find my epic ADT interface. Do you think that I want to scroll all the way down on this screen, which has hundreds and hundreds and hundreds of components looking for this darn thing? Or do we think there's an easier way? The answer, there is an easier way. And this is what we encourage all of our customers to do. There's this concept called categories. Components have categories associated with them. And essentially what that allows us to do is group like interfaces together. Typically, categories will be around message type or source target system. Sometimes they'll do it based on phase deployment. So you might have like a phase 1, phase 2. Sometimes you'll have developer names as a category so that someone can keep their like interfaces together. This is one of the decisions we make during the kickoff process, but it's very important that these categories are continued to be updated and maintained once they've been decided upon.
So one really important thing about this, because you're probably all thinking, well, what do I name this particular component for what category? You can have as many categories as you like. So, you might say ADT, you might say Epic, so you can list them, right? So ADT, Epic, and maybe a site or what have you. So the idea is that, if you're looking for ADT issues, and typically, your main source of your ADT is your EMR, it's a nice way to get a list of all the ADTs that are going out of the system. The other thing is, if you have a particular system that's down, if you have, let's say Logician, it goes down, you may need to know what other interfaces besides ADT are connected to that system. So it's a nice way of, name of the system, the type of message being sent, those kinds of things can be really helpful when you're troubleshooting.
Cool. Amazing. Haha, figured it out. Amazing. So we do have some recommendations: sending system, receiving system, message type, and we mentioned developer, deployment phases, things like that. All right, so I have my components built here. We mentioned this idea that messages don't always look the same. HL7 is a HL7 V2 will be specific, is a defined standard. Did I mess up? No, that's fine. How many people think that hospitals stick to that standard? Based on the way I'm saying it, I expect no hands. Great, good job. All right, so every single, I would even say every single implementation of every single EMR has their own specific schema. And even though it looks pretty similar in each of these different locations, they're usually slightly different. So like, for instance, we had a customer that was migrating to Epic. They got to make all of these new schemas as part of their base. And they were like, we're going to stick to the book as much as we can. We're going to stick with what Epic gave us. And even that didn't turn out quite right. And the reason why is that there's some information on a site-by-site basis or an organization-by-organization basis that needs to be communicated. The way that that's communicated varies, and the structures in which those are communicated can vary. So what does this all mean? Basically means that when you walk into a new site, a new organization, a new client, they're going to have a custom schema that we need to figure out. And sometimes it's really well defined, and sometimes it's not. But you cannot build an interface without knowing the structure first. So that is your first detective piece of work to do. A custom schema typically involves a base kind of schema to work off of. So for instance, HL7 has, what is it? We said 8 versions, right, of HL7. So usually there's some, base schema you're working off of, a 2.5, a 2.6. And then from there, there's some tweaks. Maybe EAVN is not required, which is probably the first thing that everyone does, is make EVN optional, which is your second segment in your HL7 message. You might need to make something repeating or optional. Most commonly, you have to introduce something called Z segments, which are site-specific, basically pieces of information that you stick within an HL7 message that are non-standard within the HL7 kind of body structure. So moral of the story is you're going to have all these custom schemas, or you're going to have this need for a custom schema because all these message types. All these message types are going to be slightly different. So how many do you need? I said we're going to say this a few times. As few as possible, but as many as you need. So we try to limit the number that we're working with to, a few, ideally one. Sometimes one doesn't work out, so that's why I say ideally a few. Our naming convention that we highly recommend for everyone to use is your acronym for your organization plus the base schema that you're working off of. So I think I said General Hospital something. Yeah. General Hospital Midtown, that's GHM, unless you say the base schema is 2.5, GHM 2.5. Very simple. Where we set this up for our folks who are kind of new, if we go to this interoperate section, we go to HL7, you have your schema structures here. We do have a custom schema structure for HealthShare here. But essentially what I can do is create a new schema. I give it a base, so like say 2.5.
So while she does the base, just understand that what that means is that when something comes through and you're using the schema, the message is looking at anything custom you put on top of the base. So you don't have to recreate every single message type. But if, let's say, your custom schema is for a specific message type, like an ADT AO8, you have to do something custom for that particular one. All the other ones will work.
I did an AO1, sorry.
Either way. It doesn't matter. It's just understanding that really you're just putting a layer of customization on top of that base.
So let's just say, as part of my custom schema, I have this custom segment that's transporting information called ZAL. Oh no. All right. And so, oh my gosh, guys, I cannot type today. All right. So what I'm going to do is make a custom structure for my ZAL segment, and it's going to have 3 fields in it. And so essentially what this means is that, let's say in this example, my EMR is producing an HL7 message in my AO1 segment that includes this ZAL segment, or in my AO1 message that includes this ZAL segment. And I need Health Connect to know that that segment not only exists, but to expect it. So I copied down my AO1 structure and my AO1 message. And what I can do is edit this message structure so that it's now specific to General Hospital Midtown. So one of the things I might do, honestly, like I said, the first thing a lot of people do is they make EVN optional. That is a technically not standard HL7, but it happens. Okay, so we made our EVN optional. Then one of the things I want to do is I want to take this ZAL segment that I made and I want to stick it somewhere in this HL7 message, maybe at the very bottom, we'll say.
So just for the record, Z segments by HL7 standards are supposed to be at the end of a message. If they are not, they will cause a problem.
Well,
typically.
I would say they don't cause a problem for us. But in theory, they're supposed to be at the end of a message. Commonly, you'll find them anywhere within a message. So now I'm good. I can hit save. I have my custom schema with my custom structure in it. And now if I go back to my production, I could choose to use, instead of a standard message structure, my custom message structure. And what this means is when I get a message in, I'm going to look within my custom schema and I'm going to see if I have a message structure that matches the message structure in that schema. So if I got an AO1 in, I'm going to now use this custom structure I made that has this Z segment in it. If I get an ORU in, I didn't do anything with that ORU, right? So what it does is it defaults to using the base, which is why picking the right base is important. So essentially, I made one structure. It'll default to using the base structure if I don't have one. In a typical scenario, customers define their schemas to include custom message structures for all of your kind of common HL7 messaging types. So ADT, ORUs, ORMs, SIUs, VXUs, DFTs, MDMs, the ones we've named earlier.
Yeah, and typically what you do is you run your messages through the system and you look for the errors, right? And then you just add them on and you make them optional so that they don't interfere with other message types. That's very common. And actually we have several sites that have created their, what they call their standard structure. And what they do is anything coming in or out of their system, they map to this standard structure. And the mappings that don't fit that will be done externally. So there's sometimes 2 transformations that take place. But they try to keep everything that's coming in and out of their system in this standard structure.
Any questions on schemas? Why they're important? Why we need to use them? Cool. Amazing. All right. Data transformations. All right. Where do we build data transformations? Do we use code or do we use a user interface?
Do either.
Which one should we do?
The user interface.
Good. Amazing. Smart people over here. All right. Yeah, we're going to leave that. So when we build data transformations, 9 times out of 10, 99 times out of 100, we're doing it in the user interface. Because what is our number one priority when we're building interfaces? Yes. What are people focused on when they're building interfaces? Is this the hardest thing in the world or is it? Yeah. Stay with me, people.
Ease of use.
Ease of use. So the easiest way to build an interface or a data transformation, especially if it's an HL7 data transformation, is going to be using the data transformation tool. How many people have used the data transformation tool? Yes. Good. Amazing. All right. So none of this is going to be crazy for you guys. When I build a data transformation tool, when I use a data transformation tool, the first thing we encounter our package. And this is where the debates re-arise, right? But we're sticking to our guns and we're starting with our GHM.DTL package. This means that my main folder, GHM, that's my organization. DTL is where all of the data transformations are going. Then the name. once again, wow, more debates. How did we get back to this place? But typically it'll be something like Epic ADT to lab, something like that, where it indicates source system, message type, target system, maybe target message type if it's something different. Something along the lines. We have talked about this ad nauseum at this point in time in our kickoff session. We will select an HL7 message type. Typically, we would use our custom schema that we just made, and we default to having the source be the same as the target, but obviously, if your message type is different, you would just pick a different message type. When I hit OK, you guys should be familiar with this screen. Your source on your left, your target on the right. First decision we have to make is this a new or is this a copy? This will also be a fiercely debated topic. We recommend using copies. What we typically recommend is that if you're only manipulating portions of the message, do a copy. Then you don't have to worry about bringing over every single thing, right? If it's a different message type, or if you're almost having to like rebuild the interface, or you have to remove a lot of portions of the message out of the outbound message, you might want to do a new. But I always say default to a copy unless otherwise specified. All right, so we're going to use a copy. And so what this means is my target message is the same as my source message. And then what I would do is do whatever kind of modifications I want to, I don't know, Epic. And then I would compile it. Okay. Few best practices when we're building data transforms. First thing, which I highly encourage everyone to do, is to make groups for different segments, right? So if I'm doing work on MSH, I want my MSH items to be within that group. What you can imagine is as you build out these mappings, especially complex ones, there's going to be a lot of actions, right? A lot of activity down here, and we want to stay organized. Groups and comments are very helpful for that.
So some of our larger customers, because you could have 20 different people working on the same interface over a period of time, they'll put a comment section at the very top. And it's just updates like, you know, the initials of the person and what they did. And just so that you know what's taking place. And then obviously sometimes within the mapping itself, there might be a comment at a specific location to clarify that this is where I made that change.
Exactly. Now, I won't go through all these, but there's a ton of actions in here that you guys know about. These utility functions will come up in a bit because usually there is a need to build a new one that might be specific to a customer. So we'll go through that process. But the big thing when we're building these transforms is a test as you build approach, right? When we're building a transform, as I said, you could have hundreds of different actions. When you write code, are you going to write 500 lines of code and then test it? Or are you going to write like 10 lines of code and then test it? And then if that works, then you'll move on to the next 10 and so on and so forth. Like, which way are you going to do? Once again, my voice is kind of giving it away. But which one are you going to do?
I test in production.
You test in production. Good on you. You know what? I wish I had your confidence, really. But typically what we see is people don't like to write 500 lines of code and then test it, but power to you if you're the person that loves to do late night debugging sessions. Usually we're doing more of this incremental development process, and we bring that over to UI development as well, right? So I make a couple mappings, I change some things, and then I use this testing tool, and I don't have an HL7
That's what I
message.
was going to get from.
Okay, great.
Version.
I mean, it just doesn't matter. Just any ADT, any ADT works. And so what I do is I test that message in my in that utility, in that testing tool, and then if it works the way I expect it, then I move on to the next set of mappings within my transformation, and I continue this process. So by the end of my build, I'm pretty darn confident that that transform is working as expected. Thank you very much. So actually this one has some good Z segments. So if I change this to ZAL, thank you very much.
Although it's...
That's all right, it's fine. So I can see that Epic was updated for MSH4. So that proves that that mapping worked as expected, and then I'll continue down with that process. And so we highly, highly, highly encourage this test as you build. We talk about routing rules, test as you build, critical, very important, applies to UI development as well. With that, a couple last minute items, and then we'll take a break for 10 minutes. We'll talk about the custom utility functions in a bit. People do get pretty crazy with data transformations. There's some pretty challenging things that people can do, but within the context of a data transformation, it's pretty cool. A lot of like orders, results can be a little interesting. We had one come up where they needed to actually parse the contents of a PDF document and remove the new line characters from within the PDF document that was embedded within the order message. It's a lot. So that's.
Why did they do that?
Oh, okay. That was the first thing. Other things about data transformations, typically their transformations are specific to some kind of downstream system, but there are also transforms that can be applied to all messages, right? So maybe I have a situation where every single message needs to have a truncation of a value, or I need to do a lookup, right? We call that a universal transformation. And in the context of modularity, we like defining those. So it's a build once, use many concept, and there's a single place where we update things. So you might see some customers have these universal transforms that are used across all interfaces to manipulate the data. You could chain transforms together, but moral of the story is, I don't know, maybe like 70% of the time that an interface is being built, it's on the screen. So this is where everyone's spending their time. This is where they're banging their head against the wall. This is what they need to really get working. And this is when they do ASCII comparisons. This is the results that they're comparing them against.
So if you look here, each repeating group has open close paren. I'm just going to say this real quick. This is where you can either put in a variable for looping purposes, like in this case, there's a K1 for looping. Or you could put in something very specific, in this case where we have PID group 1, ORC group 1, and then the OBX group is repeating. So I want the entire OBX group, whatever that is. So you can be very specific, you can use a variable, or you can leave it open, in which case you grab that entire repeating group. So that works with fields as well, so because some fields are repeating as well. So just something to note.
All right. Routers and routing rules. So routers are another name for a process. Actually, in Health Connect, there are different kinds of processes that you can have. The most common one in HL7 world is going to be a router. Its job is to take an HL7 message, evaluate based on some conditions whether that message is supposed to be sent out, and then send that message out the door, applying potentially some transformations in the process. Where we will find your message router is going to be not on my screen, apparently. Is going to be...
Could it also choose to not send the message?
Yes, it can also choose not to send the message. Absolutely. It is, I think, extending and not mirroring. Oh, there it goes. Wait, no, but I can't see it here. So there are two different kinds of methods that you could use with routing rules. One would be like an opt-in model where essentially you're defining what goes out the door. And then in other situations, kind of the opt-out model is your kind of, you're filtering. It's more of like a filtering approach for messages. A lot of folks end up using both. Thank you, John. Yep. John is a tech wizard. All right. So, within the, is this the right namespace?
Which one are you looking at?
I don't know.
Oh, the one I was just
here. Whatever you want. Quick dance break.
Day in the life.
Okay, that's what I thought. That was going to be my guess. All right. So within each process, you're going to have this business rule name that will allow you to launch the rule editor. What you're seeing here is the old rule editor. So we are using the old rule editor here. The new rule editor has a similar kind of, there's similar functionality to it. Essentially, the idea here is you have a set of rules, you have constraints, you have conditions, and then you have a target. Generally speaking, our customers, when they build rules, and I will not save this, John, don't worry, I won't break anything. Constraints can be helpful mainly for if there was like metadata that you wanted to filter a message on or to send a message on, those could be very helpful. I'd say most commonly though, constraints can be helpful for being able to auto-complete message structures when creating a condition. What do I mean by that? All right, let's just say I wanted to make a condition that checked to see if PV12, the patient class, was I or O. And if it's an I, then I'll send it. I can type HL7 : and then kind of type in PV1, and I think it's 2. I'm not 100% sure because I don't know HL schemas very well. Yeah, well, I'm making a story. And then I can hit OK, and then I go on my merry way. One of the beauties of using constraints, which do apply some level of filtering, but let's just say I apply a constraint that this message is going to be a type AO1. My condition now is aware of that. And so now when I try to type PV1, you're going to see I get this auto completion, and I can find patient class really easily. So if your structure gets a little bit complex, that can be really helpful for just knowing, what the actual path is to the piece of information that you're looking to do your condition on. I will say a lot of folks might use the constraint to be able to create the condition, and then they remove the constraint. That's totally fine as long as the structure stays the same. So you can use the constraint as kind of like a handhold to be able to get the condition right. And then you can remove the constraint or you can leave the constraint. But I'd say one of the best things about it is that it allows you to kind of pre-populate some things. All right, let's talk about when these things get a little bit more complicated. Typically, when you're building out these rules, there's a lot to these rules. Wow, everyone came back. Thank you. I wasn't sure, so this is awesome. All right, so let's just say I'm also checking if like MSH sending application, maybe I'm gonna do a lookup or something. I don't know if you have any lookup tables, but we'll see.
Not enough.
All right, and we'll say this is not equal to General Hospital Midtown, we'll say. Okay, so as you can see, routing rules can create branching structures with multiple conditions. One of the things that we do encourage when we're building these things out is instead, like if I wanted to add another and condition, I could go ahead and like branch another and out like that. Or what I could do is create another branch off of the same and. This is our recommendation. It makes things look a little cleaner. So instead of creating like two ands that are then connected by another and that are then connected by another and, use this branching structure. Much more simple, much easier to read. And then I can add like my ors and so on and so forth. And then I could have, multiple ors going off of that. So you can see kind of how that branching structure gets created. Amazing. Same concept with routing rules. Test as you build. So you can create, I can paste in an HL7 message, hit test, see which rules passed and which ones failed. Highly recommend for your test as you build approach to routing rule development. We'll get into a little bit how people structure these rules, but best rule of thumb here, for every service you have a process. So it's a one-to-one relationship between a service and a process. A process can send to n number of operations. So you have a one-to-one between your service and your process typically, and then a one-to-n for your process to your operation. We'll go into some kind of architectural considerations when things aren't quite that clean. Any questions on routing rules? Do we understand the idea of routing to multiple places? We talked about all those healthcare applications that need data. Great.
So there's, I would just, one thing, I would say there's a typical exception for the routing rule service to operation, or sorry, service to process. It's when you have ADTs that are going to a voluminous amount of systems where you can say, I want to have control over how those are being subdivided, because once you get to about 20 different targets, you want to start to split them up. So
That's my example.
oh my God, sorry.
You're ruining my thunder.
I didn't know you were going there.
I added it at the end at like
Okay.
12:15 just to throw a wrench in everything.
Okay.
I
Well,
got
then,
you.
good.
On the same page though. We'll talk about that. Yeah. Okay, lookup tables. Lookup tables in Health Connect mean a very specific thing. It's a key value pairing within the management portal. I will leave it so I don't save it. So under configure, you can have a lookup table. I can make a new one. I could call it gender. I can hit save. You can add female, F, apply, male, M, apply. So what this is doing is it's creating key value pairs within my database. This is very common within interfaces where there has to be some kind of lookup. We do a mapping between one code to another. When you use lookup tables, there's two main places where you'll see these used. One is in a routing rule when you're conditionally looking up something to see if you want to pass along a message. The other situation is in a data transformation where you might want to manipulate a code to a certain value depending on what the target system is. To support lookup tables, we have two main utility functions that you'll find. So if I make just like a basic action here, I'll use my data transformation as an option here. First is going to be exists. Exists is just going to do a lookup on your lookup table and return back whether or not that entry is in the lookup table. The other option is lookup. That will essentially do an exists, but it returns back to you the value associated with that key. So if you just need to see if a value is in a lookup table, you use exists. That returns back a Boolean, yes, no, 1, 0. Lookup will actually return the value that corresponds with that key within the lookup table. You will find lookup tables are very common, as I mentioned, specifically these key values. There are some situations, though, when lookups go beyond 2 values. So some folks might have crosswalk mappings or larger tables that go beyond 2 columns, in which case, lucky for us, we have an embedded database, and then we can just default to using, the typical utilities for building a standard table, right? So we might do like a create table within our SQL Explorer, or we might make a class that extends %persistent in those cases. And in that scenario, you're not limited to those 2 columns. You have n number of columns. The catch to that is just that you want to build your own utility function that then accesses that table. So there is a little bit of configuration or customization, but it is very minimal and usually something that we can teach in about a 30-minute session. Any questions on lookup tables or how we use them? Cool. All right. Amazing. All right. Custom functions. All right. We started off saying UI is number 1, right? And that is still the case. However, there are some situations where an interface analyst needs to go to code. And this really goes back to, what Randy was mentioning earlier, which is, being able to essentially tackle 80% of what you're doing in the UI, but having the option to do that additional 20%, even if it involves dropping into code, but being able to have that flexibility to do that is really paramount to our Health Connect customers. So they might flip back and forth, but it's important to note that the majority of the development that they're doing is within the user interface, and then they might have these situations where they might have to hop into code. When they hop into code, it's typically to build a utility function. Utility functions would be, basically things that interface analysts might reuse over and over again to accomplish some kind of task. Like they need to put in the age of the patient based on calculating the date of birth based on the current day time and do some kind of manipulation. That's an example of one that kind of comes up a lot. So they might create a custom function for that. And the idea is to make it modular enough for all of the analysts to be able to use it. So in a lot of situations on a team, there's maybe a one or a handful of folks that are deemed like developer mindset or oriented. And in those situations, those users are given, these tasks to develop these utilities for the team, and then they're exposed out to the whole team. They're very small, very modular. They include high-level comments so that others understand, what that function is doing, how to use it without actually having to read code. Does that make sense? Other examples of custom might involve extending existing components, like extending our HL7 adapters or things like that, though that is far, far less common. The majority of the time it's going to be building these utilities. Cool. This is a great idea or a great way to expose people to ObjectScript or embedded Python, and people usually use it as an opportunity to learn more. Yes, question.
Do you have the package naming conventions for custom functions?
Yes, it's usually, good question. We'll say General Hospital midtime, ghm.util or utils. We do, as a best practice, recommend that utility functions are each stored within their own classes. Just because if you put all of your utility functions in the same class, then you might promote something that isn't ready. But yes, that is a good question. Cool. All right. See, this is what I added. This is what John was referring to. All right. So we built, I know. So we built our first interface, if you can imagine. We have our service going to our process, which goes to our operation. We could drop a message in. We're going to run out of time if we actually go through all of that. And this is a very common structure for most interfaces. You might have a couple other operations. So consider like an ORU message. You might have that business service coming, service coming in that goes to the process, and then you have a few operations that it sends to. We mentioned ADT is a chatty Cathy, right? ADT is very voluminous, but while it is a chatty Cathy, everybody wants to hear from it, right? So it sends a lot of messages and everyone wants to hear them. So an ADT interface, what's the biggest one you've seen? Seen 1 to 200? Yeah. So a single ADT message coming in from, we'll say, your EMR could go to upwards of 200 different downstream systems. So think of that. 1 coming in, 200 going out. You can imagine that kind of falls off the screen too. And you can imagine how many different people are involved in that, vendors are involved in it. It's a very complex interface, even if it's simple from like a mapping perspective. So what does that look like? I'm showing you this to just give you a perspective of how architectures for an interface might change ever so slightly as things get a little bit more complicated. So here's our basic setup for our interface. We have our from EMR ADT, I'll change that for the PowerPoint. And then we hit our router, and then our router is sending to system 1, system 2, system 3, all the way down to system N, which in this case is 200 different boxes. So think about a situation. First of all, think about your business rules that you have configured. And also think about the fact that your one router is kind of in charge of doing all of the routing and transformation logic for all those ADTs. What are some pros and cons to this setup for an ADT that sends a ton of messages to a ton of places where there's multiple interfaces going off of the same structure? What are some, if you come up with pros, cons? Anyone see? Not besides Randy.
Then can I go?
Well, if it's simple this way, you have one router, sends everything over there. So that's
So the pro is what? Central? It's just all centralized?
Just simple.
It's simple? Okay,
Is
pro.
it simple then?
So
Well, we have a hand here. I'm sorry, what's your name again?
Kate.
Kate.
Yeah.
Yes, thank you.
If something goes wrong with the router, it's impacting all of those
Very good.
operations.
That is
that's a broad
that's a good con.
right.
Other ones people could come up with, pros and cons. That's a big one.
It doesn't fit on the screen properly.
It doesn't fit onto the screen. Yeah, absolutely. User perspective. Although we're working on that. There's a whole UX team that's working on that. Any other things people can come up with? What about a developer perspective, which are what these little users are on here?
Does it happen in serial or in parallel?
Yeah, how are they all updating this all at the same time for my source control friends? I saw Tim smile in the background. they're all updating the same thing over and over and over again, right? Because you have 200 rules. Each one of those could have 200 plus different conditions. Each one of those has its own transform, right? And then also think about it from a performance standpoint, right? I'm executing 200 rules and 200 transforms every time I have an ADT go through. So ADT is a special message that we love so dearly. So one consideration that we've talked to some folks about is maybe switching it up a little bit. So what if we still had our same one-to-one service to process, but that first process, think of it as like a pre-process. And what it's in charge of doing is really just firing messages out the door. It's routing those messages to places where it needs to be. We'll get to the second column or the third column in a second. And maybe it's doing a little bit of manipulation of that data, universal manipulation of that data. So things that every single downstream system needs to have done to that message. So now this load is pretty light. It's just firing off, right, for the most part, and tweaking things every once in a while. Now we have this introduction of it's 4 columns now, it's not 3 columns. You can see that this also has the name router. So what this is actually doing is it's taking the logic from the main router from before and it's segmenting it into individual routers. So what does that mean? Well, first of all, every time an ADT message goes through, I'm not executing 200 rules, right? I'm only executing the rules specific to my system. And I'm only executing the transformation specific to my system. So from a performance standpoint, I'm not quite parallelizing it, but kind of, right?
A lot closer.
Because each one of these is its own job on the OS and it has its own queue and it's working off of that. From a user development standpoint, yes, I have to tell my Epic ADT router to send to my new router when I make a new connection off of this ADT. But that's it, right? I'm not in there for a very long time. I'm not wrestling with other folks trying to get control of this code because all of the work that I'm doing is really in my individual routers. Now you can see my little users are on each of their own respective routers. Makes things really clean. This might be an overcomplication for something like an SIU interface. There's no reason you have to do this when you're sending to 2 different downstream systems. But for 200, it's worth the consideration. So the only reason why I bring this up is when we look at designing interfaces, we like to keep these things into consideration because performance, usability, development, ease of use, all of that comes into play. And we actually specifically cover this during kickoffs because every single organization has a chatty ADT interface and it's something they want to get right because this is the most critical of the interfaces. So I'm going to pause because I think this actually highlights a lot of pieces of the interface and how it's developed